Hello students, we are starting with mathematics today. In maths, most of the chapters are correlated with the ninth standard. But what is the chapter we are going to start today? That's trigonometry. It's completely new to you all students. So I decided to start with trigonometry so you will get more time to study about this chapter, to understand the concepts. And this is the first lecture in our online series. So hereafter, successively, I will record the lectures on the respective subjects and post it so that what are the holidays you have right now due to coronavirus pandemic, you will use it for your study purpose. So let's start with the first chapter, trigonometry. This trigonometry starts statistics parts and application parts. So statistics parts means only calculations. We are going to do the calculations only. There is no applications in this one. Application means the calculation will use for practical purpose like finding the distance, finding the height, or finding the angle. So first part of trigonometry, that is introduction to trigonometry, has only calculations about the angles, different functions and their formulas. And second part, that's some applications of trigonometry. This part consists of application problems that we'll see in the successive lectures. So if you know introduction of trigonometry very well, easily you can solve the problems which are based on the applications. So if I post any lecture, so study that lecture on the same day, make your own notes. I have given the notes so you can prefer it, you can refer it for the further calculations. If any doubt comes, definitely don't take time to ask me on the same time, on the same day, so it will be good for you. So let's start with the first chapter, introduction to trigonometry, and the next, after finishing the chapter, we'll start with the applications of trigonometry. Anyways, we are going pretty slow. We'll do all the problems, we'll solve all your doubts, so no need to worry. Just these lectures will give the clear idea about the chapter. So in the introduction of trigonometry, we have 3 or 4 sub types or sub lessons in that. The first one is trigonometric ratios. This will have all the formulas, basic formulas about trigonometry. Next we have is trigonometric ratios of complementary angles. Now the complementary angle or supplementary angle or acute angles that we studied in the lower standards. So complementary, that means if two angles are there, the sum of the two angles should be equal to 90 degrees. So we know that already. Trigonometric identities means some formulas, that basic formulas, what is required for solving the problems in case of trigonometry, that we'll see. So only I request you to study this lecture on the same day, so you will have the better idea and you will be ready for the next lecture. Since this is a first lecture on trigonometry, it is a preface of this topic. So actually studying trigonometry is, we know that's a prime importance, but we should know about about history of the trigonometry, then when we had started using this trigonometry and what were the applications in the past. Many scientists from India or scholars from India use this method to find the distance between the planets and Earth, or distance between stars. The great scholar from India or physicians is Aryabhatta also used this method. He was the first person to use it, and that words were in the Sanskrit. But whatever the modern trigonometry we are getting, the words, they are basically from the Greek word or Latin words. They have converted the Sanskrit Aryabhattam book into the Latin or Greek letters or the words. So basically, whatever the use words we are using this trigonometry, like trigonometry. So first, trigonometry implicates tri. Tri means 3. So this is the word that tri means 3 and gone. So it is a G-O-N. So this is nothing but called the side. So we are not belongs to finding the distance. This chapter does not take any point with respect to finding the distance between the planets or some kind of tricky things for the current academic year. We are just studying this chapter with respect to the simple application problems and how can we use these formulas for the further simplifying the structure of the problem. So, as name indicates, you have to study the figures or the application problems which based on the figures who have three sides. Three sides means it's we know that it's a triangle, and basically we are using the right angle triangle here. So every problems have the some concepts of right angle triangle. So all the problems, once we know the formulas, then we'll solve the all the problems based on the formulas or identities of the trigonometry. But when we move to the applications, applications have some concept of right angle triangles or supplementary angle. That supplementary angle means sum of the two angles is equal to 180 degree, or the complementary angle, that means sum of two angles is equal to 90 degree, or acute angle, that means the angle should have the value less than 90 degree, or right angle means the sum is equal to 90 degree, or the angle value is equal to 90 degree. So these all the concepts we are using in the these chapters. Once we go ahead, we'll see problem by problem, so you will not confused and you will get the clear idea about this topic. So as we're discussing about just little bit about the trigonometry, now I have just drawn here some application problems. Suppose this is the building. This is a building, four-story building, and this is the ground surface. यहाँ पे एक आदमी है. This was a man standing here. He is looking towards the building. Now the distance of the building from the man is given already in the problem. That's 200 meters. That means this man is standing at 200 meters away from the building, and the angle from the point where the man is standing to the top of the building is 30 degrees. And they ask you to find the height of the building. So some kind of things, because height of the building without measuring, calculate the height of the building. They will give you the angle, the distance, and all kind of things. So this kind of problems we can solve easily by using the applications of trigonometry. Now see here, this is a 30-degree angle which is making out, and this is the distance of the man from the building is 200 meters, and find the height of the tower or the building. So this is how they can ask the application problem. So to solve this type of problems, if you look clearly to this figure, you will find out there is a right angle triangle forming here. That means there is the angle, the building which is making with respect to the ground is 90 degrees. So we can say this triangle, whatever the form, is the right angle triangle. That means one thing is clear, we are going to use the right angle triangle properties and the Pythagoras theorem or Pythagorean theorem, whatever you say. Both the names are correct. Some books has Pythagoras, some will say Pythagorean theorem, and this theorem is studied since from the lower classes. That is hypotenuse square is equal to side square plus side square, and side opposite to, this is the hypotenuse because the side opposite to 90 degree. This is the right angle, and the opposite side or the longest side of the triangle is called the hypotenuse. To remember this one, you can just see, no need to confuse which will be the hypotenuse. You just see the 90 degree angle and just opposite to 90 degree angle, that will be your hypotenuse. So this is the application problem. They may ask you in the exams, and this chapter is of prime importance with respect to board exams, because most of the times they will ask you one 2-mark question and the long answer question from the same chapter. So study it clearly, understand the concepts very well, and if any doubts are there, please ask me. So we'll just, after explaining the pieces of this topic, we'll just go to the first subtopic of this chapter. It's the trigonometric ratio. Remember, there are only 6 trigonometric ratios. So first is sine, S-I-N, that's sine. Next is called the cos, C-O-S, cos. Next is called the tan, T-A-N, tan. Next is cot, C-O-T, cot. Next is sec, S-E-C, sec. Next is cosec, C-O-S-E-C, cosec. Now this 1, 2, 3, 4, 5, and 6. So these are the 6 trigonometric ratios. Out of that, the sine and cos are called the original trigonometric ratios, or the non-derived trigonometric ratios, because these are the two ratios which were present in ancient times. So after that, tan, cot, sec, or cosec, they are the derived one. Derived one is what? We can find the tan value once we know the sin and cos, or we can find the cot value once we know the tan value. So that means is tan, cot, sec, and cosec. With all the four values we can find if we know the values of sin and cos. The sin and cos, these ratios are the ancient ones, firstly found out, and then on the basis of that, depends on the requirement, they found the tan, cot, sec, and the cosec. So to understand the relations between the two sides and the hypotenuse of the right angle triangle, I will derive all the formulas of all the six ratios. So let's take this triangle ABC, which is right angled at B. That means angle B is 90 degree. As I explained you, the side opposite to 90 degree is the hypotenuse. So of course this is the longest side of the triangle and that will become hypotenuse. Now this is the perpendicular and this is the base of the triangle. So we'll see how the formula of sin A comes. Sin A indicates what? Angle. Now see here, I am taking the angle of this triangle here. So I will find the formulas for angle A. Even you can go for angle C, but let's see for the A and then we'll go to the C. Now sin A. So for sin A, we have formula opposite side upon hypotenuse. Now this is angle A. For angle A, opposite side means just opposite to it is BC, and hypotenuse is nothing but the AC. So the sin A formula is opposite side upon hypotenuse. That you have to remember, you have to mug up. So opposite side upon hypotenuse will become opposite is BC upon AC. So sin A formula, opposite side upon hypotenuse, that is nothing but equal to BC upon AC. That's our first formula. Next is cos A. Cos A is adjacent side upon hypotenuse. So take this angle A. Adjacent means just side of it. So this will become the adjacent side, that's AB, and hypotenuse, that will be the AC. So cos A is equal to adjacent side upon hypotenuse, that is nothing but the AB upon AC. Next we'll go. Next is tan A. So again this angle A. Tan A formula is opposite side upon adjacent side. So opposite side is nothing but BC and adjacent side is nothing but the AB. So we will find out the BC upon AB. So this is what the basic formula, but remember one more formula for tan. It will be the sin A upon cos A. So as I told you, tan A is a derived one. Once I know the sin and cos, just divide both, you will get the tan value. Or you can use the primary formula, opposite side upon adjacent side, that is nothing but BC upon AB. Whatever you like it, you can use it. So next, if we go for the cot A primary formula is adjacent side upon opposite side. So adjacent side is nothing but the AB and the opposite side is the BC. So AB upon BC also you can write. Otherwise, cot A is the reciprocal of tan A. That means cot A is equal to 1 upon tan A also we can say. Otherwise, we can say cos A upon sin A. So whether you can use this one, otherwise you can use this one, or you can use this one, or this is all the formulas you can remember it. So next is sec A. Sec A is nothing but the hypotenuse upon adjacent side. So hypotenuse is nothing but the AC, adjacent side is nothing but the AB. This is what the basic one. Otherwise, sec A is a reciprocal of cos A. That means sec A is equal to 1 upon cos A. We can easily write down. Next is cosec A. Cosec A nothing but the hypotenuse upon opposite side. So hypotenuse is nothing but the AC and opposite side is nothing but the BC. So AC upon BC. Otherwise, cosec A is a reciprocal of sin A. So we can write 1 upon sin A. So since cosec A is equal to 1 upon sin A, for sin A also we can write 1 upon cosec A because it's vice versa. So you can write cosec A here. Since sec A is equal to 1 upon cos A, so cos A also we can write as a 1 upon sec A. So this all the formulas are basic formulas before starting the trigonometry. So you should know the concept and the basic fundamental formulas to move ahead. In the previous slide, we explained the trigonometric ratios for angle A. Now I am giving the homework to you all of you students that I want the trigonometric ratios formulas for angle C. So by using this, by preferring the last slide, you have to just find the all trigonometric ratios for the angle C, and you can just take the peek of it and you can send me on the WhatsApp, so I will check and reply to you. So this is the first homework question, that you have to find the trigonometric ratios of angle C. That means sin C, cos C, tan C, sec C, cosec C and cot C. Everything I should know in terms of sides. And next question I've asked you, can I find the trigonometric ratios or the value of angle B? So this is also the question. You can just say yes or no, or if yes then why, if no then why not, you reply me. Now by explaining all kind of formulas, now we'll go to the first sum, that is example 1. What I given here is, this is triangle PQR, in which PQ is equal to 12 centimeter I given, and PR, that's the hypotenuse, because 90 degree just opposite side and it's the longest side of triangle, it will be 13 centimeter. And I have to find the ratios for angle P and also ratios for angle R. So I will find the ratios of angle P and I will give homework as to find the ratios of for angle R. All the 6 trigonometric ratios we have to find out. Let's start with that. So first of all, when the problem comes to you in the exam or for the practice, you should know, you just find out whether all the sides of the triangles are given or not. Now suppose PQ is given by 12, PR is given 13. Now this side is completely unknown, this is not given, this was I wrote after my calculation. So this is PQ is 12, PR is 13 and QR is, we have to find out, because the basic fundamental we require to find the sides of triangle first and then move to the formulas. Now I have used the Pythagorean theorem, or you can say even Pythagoras, whatever theorem. So it is hypotenuse square is equal to side square plus side squares. See, some books they are using base square plus perpendicular square and all kind of things, but it is little confusing for you people. So side and side, that's quite synonyms. So use that formula only. So hypotenuse square is equal to side square plus side square. So I used here. Now hypotenuse is my PR, so PR square plus is equal to PQ square plus QR square. I have done it. So PR is given 13, PQ is given 12, and QR we have to find out. 13 square is 169, 12 square is 144, QR square just minus 169 from 144 from 169, you will get the 25, and QR is equal to root of 25, because I want QR, not QR square. So QR getting means find the square root of 25, you will get the 5. So once we found the QR, so the basic condition to know all the sides is completed. So now we'll go to all the ratios. So sin P ke liye we know that it is the opposite side upon the hypotenuse. So opposite is 5, hypotenuse 13, so my answer is 5 by 13. Cos P, we know adjacent side upon hypotenuse, so P ke liye adjacent is PQ and hypotenuse is PR, so 12 by 13, that's done. Next is tan P. Tan P ke liye I told you the formula, you can use the sin P upon cos P. Otherwise another formula, opposite side upon adjacent side. Sin P upon cos P means 5 by 13 upon 12 by 13, 13 13 cancel, 5 by 12 will come, that's answer. Otherwise normal formula, opposite side upon adjacent side, opposite side is 5, adjacent side is 12, you will get the answer 5 by 12. Now after tan we will find for cot P is equal to adjacent side upon opposite side, or you can say 1 upon tan P. This is tan P, I applied, I made the mistake here. 1 upon tan P, that's nothing but opposite side is 12, sorry, adjacent side is 12, opposite side is 5, so answer is 12 by 5. Next is sec P. Sec formula we know, hypotenuse upon adjacent side, hypotenuse is a PR, adjacent side is PQ, so 13 by 12. Next is cosec P. Cosec P is equal to hypotenuse on opposite side, hypotenuse is nothing but the PR, opposite side is a QR, so we can 13 by 5. So in this way we can find the ratios of all the 6 trigonometric ratio, but you should know what is the angle. Why I am saying you should know what is the angle, because suppose let's take this triangle we discussed before. Now if you are taking angle A, this will be the adjacent side, this will be the opposite side. But if you take the angle C, for angle C, so the opposite and adjacent sides for angle A and angle C are different, because if you take the angle C, AB will become the opposite side and BC will become the adjacent side. So you should be very careful which angle you are taking, whether you are taking the angle A or whether you are taking the angle C. Now to end up this lecture, I will just give the homework sums. In the last example, I have explained the angles for angle P, all the ratios for angle P. You have to find all the ratios and its values for angle R. And another homework question I have given, a right angle triangle ABC, which is right angle at B. AB they have given, BC they have given. You have to find the AC because they are not given, and you have to find all the 6 trigonometric ratios for the angle A and angle C. So this all the questions you have to solve. Next lecture tomorrow we will post it.